Have you ever imagined life beyond Earth, not on a distant planet, but on a moon? When we think about aliens, we picture other Earth-like planets orbiting distant stars. But what if we've been looking in the wrong place all along? What if the real cradles of life are moons? Here in our solar system, the most promising places to find life aren't planets like Mars or Venus. They're icy moons, like Europa and Enceladus, that hide vast oceans beneath their frozen surfaces. These oceans might be warm, rich in chemicals, and possibly teeming with alien life. Now imagine a moon orbiting a planet in another star system, a place where tides create heat, water flows beneath ice, and conditions for life could quietly thrive, without needing sunlight at all. Could it be that the first alien life we discover doesn't come from another Earth but from another moon? This isn't just science fiction anymore. It's a real question driving space missions, telescopes, and scientists around the world. So today, we dive into a simple yet profound question: life on an alien moon, science or sci-fi? For decades, the search for alien life focused on Earth-like planets, rocky worlds with water, an atmosphere, and just the right distance from their stars. But science has shifted. Today, many of the best candidates for hosting life aren't planets at all. They're moons. In our solar system, Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, have become frontline contenders in the hunt for life. Why? Because beneath their thick layers of ice lie vast oceans, potentially larger than Earth's. And thanks to gravitational forces from their host planets, these moons experience tidal heating, creating energy and possibly keeping those oceans warm and stable for billions of years. No sunlight needed, just chemistry, water, and heat, the essential ingredients for life. This realization has launched new missions. NASA's Europa Clipper, set to launch soon, will scan Europa's ice for signs of life. Other missions aim to dive into subsurface oceans with robotic probes. But the real game changer? The idea that exomoons, moons orbiting planets outside our solar system, could have similar conditions. Though harder to detect than planets, exomoons could be even more common. And some scientists believe they may be the most habitable worlds in the universe. We often think of life as something that flourishes under the warmth of a sun, on green lands, under blue skies. But Earth itself tells a different story. At the bottom of our oceans, far from sunlight, life thrives. Around hydrothermal vents, entire ecosystems survive purely on chemical energy. Microorganisms feed off minerals. Tube worms, clams, and crabs live without ever seeing the sun. No plants, no photosynthesis. These deep-sea creatures prove that life doesn't need starlight. It needs energy, and a medium like water to carry it. This changes everything. Because moons like Europa or Enceladus could host similar hydrothermal vents beneath their icy crusts, fueled by tidal heating. There could be warm pockets, rich in minerals, and if life started, it might still be there, thriving in complete darkness. Even more compelling, Earth's extreme life forms, called extremophiles, have been found in boiling acid lakes, Arctic ice, and even inside rocks. They stretch our understanding of biology and redefine what's habitable. So if Earth can support life in places that seem impossible, why not a distant alien moon? What once seemed like science fiction, oceans under ice, life without sunlight, is now observable fact. And it makes the possibility of life on exomoons not just plausible, but almost logical. If alien moons could host life, the next question is obvious. How do we reach them? In our own solar system, NASA is getting ready. The Europa Clipper, launching in the next few years, will orbit Jupiter and make dozens of close flybys around Europa. It'll scan its icy surface with radar, magnetometers, and spectrometers, looking for water, salts, and signs of something stirring beneath. Then comes the dream, drilling through the ice. NASA and other agencies are testing cryobots, heat-powered robots that can melt through kilometers of ice to reach alien oceans. Once beneath the surface, small submersible robots like SWIM, sensing with independent micro-swimmers, could explore the dark seas, mapping terrain and sampling water for organic molecules. Beyond our solar system, the challenge is harder, but not impossible. Space telescopes like the James Webb and future missions like LUVOIR or the Life Interferometer aim to detect exomoons by watching how they wobble their host planets, dim starlight, or shift spectral lines. If successful, these instruments could even detect atmospheres or chemical signs of life on exomoons. The technology is moving fast. What once sounded like science fiction is now blueprints on engineers' desks. Step by step, humans are pushing the boundary, from scanning icy crusts to diving alien oceans to watching distant stars for the faintest ripple. That might one day whisper, "Life was here." The year is 2042. After 7 years of flight, the cryoglider finally touches down on Europa. From orbit, Earth watches nervously as the robot begins its descent. It carries one mission: to melt through 15 kilometers of alien ice. Days pass, then weeks. Finally, a signal. Water contact confirmed. The cryobot has reached the subsurface ocean, dark, pressurized, ancient. Inside its belly, 6 tiny robotic swimmers, each no bigger than a pencil, deploy into the unknown. The first hours show nothing but salt, motionless water, and icy walls. Then, something moves. One microswimmer catches a glimpse of a strange flow, like a plume of heated water from the seafloor. In the turbulence, particles swirl, shapes flicker, molecules appear that shouldn't form naturally. The robot's onboard spectrometer stutters. The data it sends shows complex carbon chains, amino acids, and something even stranger, a possible RNA fragment. Earth holds its breath. It's not proof, not yet. But the pattern is deliberate, structured, the kind that life creates, even in its simplest form. Back on Earth, headlines erupt. Some celebrate, others doubt. But one truth stands. We've touched another ocean, and something may have touched back. We didn't find cities, we didn't find aliens, but maybe, just maybe, we found a beginning. For centuries, we looked up at the stars and dreamed of alien worlds, vibrant planets circling distant suns. But what if the most likely places to find life are not planets at all? What if the answer has been quietly orbiting, hidden in the shadows of giants? Exomoons challenge everything we thought we knew. They blur the lines between planet and satellite, between what's habitable and what's just, cold and lifeless. They show us that life doesn't need continents or sunlight, just the right ingredients in the right pocket of space. They remind us that the cosmos doesn't follow our expectations. As telescopes sharpen and probes dive deeper, we're forced to rethink our assumptions. Maybe the next Earth isn't Earth-like. Maybe it's a dark ocean beneath a frozen shell. Maybe life finds a way not because conditions are perfect, but because life is stubborn, creative, and relentless. This changes the question. From "are we alone?" to something even more humbling. How many kinds of life have we not even imagined? And so, the search continues, not just for aliens, but for new definitions of what it means to be alive.